afternoon. My name is Natalie Gilbert, and the title of my experiment is Puzzling Polymers. The question that I asked is simple. I asked, can a polymer made from the same ingredients take on different physical attributes? I asked this question because one day, when I was doing the recycle, I wondered why some things had different numbers. I asked my dad, and he said that they were made of different things. This still didn't explain why things with the same number could be so different. This is why I did my experiment. My hypothesis is the following. By mixing different ratios of ingredients, I will directly affect the physical composition of a polymer. I thought this because when different monomers form together, they create a different polymer. Here's an example. Let's say that boys represent one polymer and girls represent another. If I combined all boys together, I would have a boy polymer. But if I joined boys and girls together, I would have a boy-girl polymer. Because it's made of different monomers, it's a different polymer. This fact is key information to making my hypothesis. To understand my experiment better, you have to know what a monomer is and what a polymer is. A monomer is a molecule that when bonded together with other monomers creates a polymer. A polymer is something made up chiefly or mainly of monomers bonded together. This is the scientific principle my experiment tests. The effects a changing ratio of ingredients will have on a polymer. This says that a different amount of ingredients probably does affect the polymer. But what changes will happen? This is what I was going to find out. I need a few items, including Ziploc bags, water, Elmer's school glue, borax, a scale, jars with lids, marker, exam gloves, and food coloring to complete my experiment. Here's the procedure I followed for my experiment. First, prepare the 50% glue solution, which is made up of 50% glue and 50% water, by using the following instructions. Add 200 milliliters of glue and 200 milliliters of water to one of the jars. Tightly secure the lid on the jar and shake until the glue is fully diluted and no gooey clumps remain. Using a permanent marker, label this jar 50% glue. Next, prepare the borax solution, which is made up of 4% borax diluted in water. Weigh 10 grams of borax and 250 grams of warm water, then add to the jar. Tightly secure the lid to the jar and shake until no particles of borax remain and the solution is clear. Using a permanent marker, label this jar 4% borax. Now create the slime by adding 50% glue and 4% borax solutions together in different ratios to see what properties the final mixtures will have. For each mixture, first add the amount of the 50% glue solution to a Ziploc bag. Then add the required amount of the 4% borax solution to the bag. For example, to get solution number 3, you add 44 milliliters of glue and 15 milliliters of borax. Seal the bag and use your fingers to squish the mixture around to mix together the ingredients. Try adding food coloring to the mixtures before mixing. Make sure to add the same amount of food coloring to each mixture so that the coloring is a controlled variable. When the mixture begins to form a sticky glob, take it out of the bag. Write down your description of the physical properties of your resulting substance on the table. I used words such as runny, slimy, sticky, hard, and bouncy to differentiate my results. Record what ratio of ingredients produced the best result. One issue that I ran into while experimenting was that the yellow polymer was unable to be taken out of the bag. I solved this by observing it while in the bag. Although I was not able to form or shape it as I was the other examples, I was still able to touch it and got a satisfactory results from my observations. In the end of my experiment, my hypothesis was 100% accurate. The different ratios of ingredients did affect the physical characteristics of a polymer. Some were rubbery and some were gooey. Figure A1 was runny and it very much resembled water, whereas figure A2 was thicker and less runny. As shown in my chart, figure A3 was very much like rubber. It was hard and surprisingly bouncy. Last, there is figure A4. It was the hardest and it was not bouncy at all. Through my experiment, you can better understand polymers. Polymers are a little puzzling, but they are critical to our everyday life. Thank you.